Are you a teacher or a teaching assistant in physical geography? Are you looking for new ways to engage your students, deepen their knowledge of Earth's processes, and introduce them to new technology while preparing them for the job market? Well, we have a solution for you. Meet the latest addition to your course, GeoProgress. Large lecture-style introductory physical geography courses are where many students experience college-level science for the first time. There is a concern that large lectures contribute to student disengagement, and there is a need to create ways for students to remain engaged. When the additional lab and assignments are presented in the same passive way that don't allow for student exploration, a disengaging environment is created, and this may prevent further interest in the subject. This is a huge downfall for introductory physical geography courses, as physical Earth processes can be measured with a suite of technology and are often intertwined with complex social problems in an environment. Redesigning how physical geography is taught is not a new idea, as many researchers are already discussing how introductory courses and associated labs can be more student-oriented rather than providing solely passive learning. With increasing undergraduate enrollment, there will likely not be a move away from lecture-based instruction, as this is a method that can relay information to a large group of people. But lecture and discussion sections along with assignments can be improved. The use of GeoProgress in an introductory physical geography course provides the opportunity to train students in techniques used in the discipline, as well as expose them to various styles of learning through animation and data visualization. By using GeoProgress, students leave the course with professional skills that can translate to other courses and into the workforce. Through 3D visualization softwares like Google Earth or Geographic Information System, also known as GIS, students will feel like they have the Earth in their hands, as they do right on their computer. GeoProgress is a teaching concept with the goal of increasing student engagement, preparing students to solve complicated problems, and promoting deeper learning in course material through the use of technology and active learning. Let's see an example of how this works. You lecture about rivers and runoff and present students with definitions to new concepts. You use an animation or YouTube video to show how this happens in certain environments. You then assign the students a lab based on these concepts with the goal of introducing them to 1, using a new technology, 2, using open source data of real river volumes, and 3, how this can affect populations near rivers. The widely popular and free Google Earth allows students to interact with landscapes across the world at various time periods through historical imagery and new 3D reconstruction of certain environments. In the assignment description, you give students step-by-step on how to navigate Google Earth to find answers to questions like measure the width of the floodplain in 5 different locations. Encourage them to explore. What type of infrastructure is near the river? Why might people have been subjected to live in the floodplain of a freely flooding river? For the assignment, access data for the river from USGS. It's a free data source that allows users to see volume changes in rivers. Have students make a graph representing change in river volume over time. Provide step-by-step instructions for students who may have never made a graph before, but encourage them to explore outside of the assignment. What else might we learn about rivers to better understand flooding? How might we graph that? At the end of the assignment, students will have related lecture material, videos, and real data to physical processes on Earth while becoming introduced to new technology, building professional skills, and applying their knowledge to real-world problems. This is just one example, but the possibilities are endless with technologies in GIS as well as close-range remote sensing. This is student improvement. This is GeoProgress.